Swayam Prabha. Digital India. Educated India.
तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Hi, in this particular clipping let us try and understand what a rigid body is, how do we determine the degrees of freedom of a rigid body. Before going into details, let us just look at how do we describe the motion of a particular body. Okay. I have this watch over here, it has a strap, I am just going to remove it for you to get an idea. If I look at this watch has a motion that I can describe. In addition, it can also be very flexible, or in other words each point of this body can move relative to each other. Okay. We call this as a flexible body. On the other hand, supposing I take a body like this and I want to describe the motion of this body, okay. Let us say it is moving like this. If you look at it, whatever be the kind of force that we apply on this, reasonable, you do not see that much of deflection, that much of motion between the points of the body, okay. And for all practical purposes I can define this body as a body whose lengths remain intact while in motion, okay. Or in other words we call such a body as a rigid body, alright. So in this exercise we will just look at only the rigid bodies, okay. Now the rigid body can move like this, can move upward, it can move towards me or away from me, it can rotate about an axis which is pointing towards you, it can rotate in the about the horizontal axis, and it can rotate about the vertical axis, okay. So there are 3 translations and 3 rotations possible in a general rigid body. Alright. In order to make understanding clear, let us just reduce that to a body that has lesser number of ways of motion. For example, if I take this board and a body on this board attached to this board, okay, and if I want to describe this body, let us say it is a rigid body, there are 3 ways in which it can move. It can move horizontally like this, it can move vertically like this, or it can rotate about an axis, alright. So in a planar rigid body, I can expect 2 translations and a single rotation, okay. One of the important points to note here is if I have to describe the vertical motion, okay, that is completely independent of what is happening in the horizontal motion, okay. For example, if it is going like a wave and if I have to describe only the vertical motion, it in no way affects the horizontal motion, or in other words the 2 translations that I describe are independent of each other, okay. So I am going to add one more term over here, 2 independent translations and an independent rotation, okay. This word independent is a very important addition to it, okay. So in all it is possible to have three quantities which are independent that can describe the motion of a rigid body like this, alright. So, we call this as 3 degrees of freedom. Are you with me? So, in general what we say is for a planar rigid body, okay, there are 3 degrees of freedom possible, okay. So, if I have to draw a body here, as I described, there is a possibility of motion in this direction, okay. So, let me just use horizontal and vertical directions as 2 independent quantities. Let me call this as x and this as y. So, the displacement in the x direction let me call as say u, and the displacement in the y direction as v, and there is a rotation possible, let us say theta, okay. So, I am going to just say rotation theta, alright. So, there are 3 degrees of freedom that I can use. One is a translation u, one is a translation v, and a rotation theta, okay. Given these 3 values, I can tell you the position of this particular body that I have, okay. What are the other important things? I have to have a particular frame that I define for what is 0 displacement in x direction, what is 0 displacement in y direction, and what is 0 rotation that we have defined here, okay. So, we can say we have an origin which specifies 0 displacement in x and y directions, and the horizontal axis can be taken as a reference axis, okay. So, if I have the body here and if I draw these axes on it, okay, and let us say it gets attached to this. So, let me call this as O, I take this and I attach it over here, and then start to define the displacement in horizontal direction and vertical direction and its rotation. It is possible to describe the motion of this planar body on this board completely, okay. This basically tells us that if I have a planar rigid body, I should expect a maximum of 3 degrees of freedom. Let me explain a little bit more. So, let us say this is the rigid body that I am looking at, this is a planar rigid body, and it can move anywhere like this, it can also rotate, okay, as we have already talked about it earlier, okay. So, let me just take a point here, okay, mark it as say A, okay. Now, if I fix this with a pin, how many degrees of freedom will it have? If you look at it, the only way that I can move this body is by rotating it, okay. Forget about the planar motion, it is only the horizontal motion, that to a rotation, that is possible, okay. So, one way of describing any point on this rigid body is with respect to this particular point A, mind you, with respect to this particular point A, I can define the motion of any other point on the body by simply knowing the amount of rotation it has undergone with respect to an axis, okay. If this is an axis, how much rotation it has undergone, alright. Every point will have undergone the same rotation, which is an important idea to remember, okay. The other distance that you have to take care of in order to know how much motion has occurred is a fixed point. The distance between that point and let us say another point that I choose over here does not change during this particular motion, okay. Or in other words, if I fix a point on the rigid body, the only way that it can move is by rotating, which means it reduces to one single degree of freedom that I have to define in order to understand the motion of this rigid body, okay. And mind you, this is all with respect to a point that I have fixed. Now, supposing I let this particular point move around, okay, am just going to do it like this. If I let this particular point move around and then also rotate about this, since I have already defined the rotation of this particular body with respect to A, okay, the additional degrees of freedom come about by looking at the motion of this point A, okay, alright. How many degrees of freedom are possible? 2 degrees of freedom are possible for this particular point A to move around. This we already know because a particle has 2 degrees of freedom, one in one x axis, the other along the y axis, alright. Once we have this concept right, we will move on to the systems of rigid bodies, so that we get an understanding of how to define the degrees of freedom. This is very essential before we go on to understanding how to write the equations of motion to solve the problem. Thank you.